Okay, this is a half-life problem. Half-lives, like, let's just say, and it's giving us, doesn't tell us an amount, it just tells us a percentage, but let's say that you started out with 100% of that tree, okay? And let's talk about what half of that is. If you take half of the tree, you would end up with like 50% of that tree, right? But that doesn't happen in 1 year, because it takes 5,600 years. If you have 1 year up here, that's only 1/5600th of how long it takes to get to 50% of the tree that's left. Okay? So, what this problem is saying really, and I want you to notice that 1, that's the number of years. So if I put T for time in years, because it takes 5,600 years for this to half, then your exponent is going to be, instead of just T for time, it's going to be T over 5,600. Because it's half-life, the base is 1/2. So if you start with 100 and multiply that times 1/2 times T over 5,600, it wants to know how long does it take to end up with 1.75%. All right, so let's take a look at this. What I need to do is somehow get that T way up there isolated. When the T is in the exponent's place, the first thing to do is to isolate just the entire exponential part of the expression. So I need this whole thing alone first. All right, and what I'm going to do to get it alone is divide both sides by 100. So I'll end up with 1/2 to the power of T divided by 5,600 is equal to 1.75 divided by 100 is going to bump that decimal place back 2 more times. So it's going to be 0.0175. Now, I'm going to tell you that what I'm going to do is use the calculator. I'll quickly show you at the end here how you would solve this manually, but you could just do this. Just go, okay, let's make y of x equal to, open parenthesis, 1/2, close parenthesis, to the power of, it's to the power of more than one thing, so I've got to put that in parentheses. Okay, it's going to be to the power of, remember you can't use t, you have to just use x instead, so x divided by 5,600, and I'm going to close that parenthesis. Okay, and I'm just going to click OK. Now what I'm going to do is go to the table, and what I want is, I'm going to start it at different x values. So let's start this at, by the way, can you tell that if it would take 5,600 years to get to 50, I'm way less than that. So I'm going to let it move in like 100-year increments, and let's do 1,000 first. And then I'm going to start it at, it's got to be bigger than 5,600. I'm going to start at 10,000 and see what's happening here. Okay. I want you to notice that to end up with 0.0175. I'm getting there, but I'm not there yet. 0.0175 is somewhere between 32,000 and 33,000. It's definitely not 33,000, and it's definitely not exactly 32. Well, hold on. Let's look. 0.01. It's in between 32 and 33. Okay. So it's not 30 and it's not 22. I do know that. That is way different than the answers here. Let's do this. Let's, instead of having it change, let's have it start at, I know that 32,000 is what's in question. And instead of having it step by years of 1,000, let's do 250 years at a time. And then look and see which one's closer to 0.175. And I'm kind of off here, so 0.175 is really a lot closer, I think, to 33 than it is to 32. Can you see that 33 is 0.168 and 32 is 0.19, and that's a big difference. And so we could tell it to change in 100 increments. And then let's look and see between 33. Keep in mind that for it to round to 33, it has to be bigger, at or bigger than 32.5. So 32.5, look here. For it to round to 32, it's got to be closer here. So actually, I think 33,000 looks like it is the answer to this question, because 32.7 rounds a lot closer to 33. Now let me show you how we would do this exactly. So I'm going to guess, well, shoot, what was my guess? I think I said 33. Yeah, A. All right. Let's take a look, though, at the way that you would do this with your calculator and with your log rules. If I took the log of both sides, okay, remember the log rule that says that if you've got an exponent, it can come sit right here. So this becomes t over 5,600 times the log of 1/2 is equal to the log of 0.0175. Okay, so if I want to solve this, remember log of 1/2, your calculator can do that easily, and the log of 0.0175. So I am going to, first, I need to isolate t, and sometimes I have to remind myself, wait a minute, what am I doing? So the first thing I'm going to do is multiply both sides of this equation times 5,600 times 5,600. Okay, so now I've got t times the log of 1/2 is equal to 5,600 times the log of 0.0175. Now I'm going to divide both sides by the log of 1/2, which is just some ugly number. All right, and now t is isolated. So all I've got to do is pick up the calculator and just make sure that when I type in this equation that I remember that, first of all, you've got to do the entire numerator divided by the entire denominator, and so parentheses are going to be super important. So looking at this, I'm going to just enter in open parenthesis 5,600, oops, I didn't get it, hold on, open parenthesis 5,600 times the log of 0.0175. Okay, and now I'm just going to double check. I closed the 0.0175 and I've closed the entire numerator, divided by open parenthesis log of 1/2, and it's already closed. So I've closed the 1/2. Now I'm closing the denominator and hit enter. That's 32,684, which is a little bit too high to be rounded down to 33. So, down to 32. So the answer is 33, and that is A.